this is hydrogen, which is the first element of the periodic table. And elements are always shown in a box where there is a letter or letters in the middle. And at the top, there will always be two numbers on the left and on the right. On the left symbolizes the atomic number. And since the atomic number is 1 for hydrogen, that means that hydrogen is the first element of the periodic table. But on the right will always be another number that symbolizes the mass of this element. So how heavy is this element? Now you may ask, what exactly is an element? And an element is a substance that is made of one atom. So hydrogen is made up of one atom, but you may ask, what is an atom? And to answer that question, an atom is more or less everything. An atom is the building blocks of all materials. Atoms are absolutely everywhere. You can't see them though, but they're there. And atoms are composed of three things. They're composed of electrons, neutrons, and protons. How these atoms may look, how you may ask, looks a little something like this. So we're going to draw a box and inside will be an atom. So we have this big circle and then we have another circle. And let's say that this atom represents hydrogen, which is up here. Now, when we talk about electrons, neutrons, and protons, we have to differentiate of the places on which these go in like atomic structures. So neutrons and protons, they both belong in the nucleus. So the nucleus is this big circle in the middle. And sometimes people, they can do two things. In the middle of the nucleus, you can either write H, which is the symbol of the element, or you can divide this into half and write neutron and proton. And I'm going to write neutron and proton just for the sake of explaining the places. So neutron and proton, they both belong in the nucleus. Meanwhile, the electrons, they're the smallest of the other compositions, and they belong on the orbits or the orbitals, and they are right around the nucleus. So with hydrogen, there is one electron. So you can just draw a circle or an X anywhere on the orbital. So just to repeat myself again, neutrons and protons, they both belong in the nucleus. Meanwhile, electrons, they belong on the orbitals that continuously circulate the nucleus. To differentiate between the two of elements and atoms is that elements, they're everywhere. And an element is made up of one atom. And those atoms are the building blocks of everything. Like atoms are absolutely everywhere. And those atoms would have different elements composed within them. Now, when we look at electrons, neutrons, and protons, we have to differentiate their charges. Now, you may ask, what's a charge? What's the point of a charge? Well, what's the point of a charge is charges always have a goal where they want to become stable atoms. So hydrogen, for example, is not a stable atom because it only has one electron in its orbit. If it was stable, it would have two electrons in its orbit because that's how the orbits are made of. That's how the atomic structure is. So that means that hydrogen is more or less not satisfied and it's not a stable atom. So they will try to give the electron away or try to take another electron. So in order for there to be two electrons within the orbit for them to be stable and for them to be happy enough, I guess. But we're going to go more into that in the next video. But to clarify some things, neutrons, protons, electrons. Electrons have a negative charge. Neutrons have a neutral charge, or 0, and protons have a positive charge. Now, to help you with that, P is for positive, so it has a positive charge. Then for neutrons, N is for neutral, so it has a neutral charge, or the same as is 0. And then electrons has a negative charge. Let's go a little more in depth into the diagrams into the atomic structures of different elements. So we've already looked at hydrogen. Let's look at beryllium. So beryllium is the fourth element of the periodic table. So that means beryllium will look like something like this. So we have the symbol, B stands for beryllium. We have the number on the left-hand corner, which stands for the atomic number, because beryllium is the fourth in the periodic table. And then on the left, we'll have its mass, which is 9.012. Now we can take this and draw its diagram. So we have the nucleus once again, and then again, you can take the symbol of the element and put it as the nucleus, or you can divide this up into neutrons and protons. Then we have our first orbit, and then we're going to have our second orbit. What we have to do is just set a ground rule, the orbital rules. So as mentioned, within the first orbit, there can only be 2 electrons, and only 2. That is the limit. But from beyond that, from the second orbital, the third orbital, fourth, fifth, sixth, seventh, doesn't matter how many orbitals there are, but beyond the first orbital, there can only be 8 electrons on the orbital. So let's do this. We have beryllium is the atomic number of 4. We have to do 4 electrons then. So that means 2 electrons will go into the first orbit and only 2. And that's our limit. It cannot be more than that. So then we turn to the second orbital and go, okay, so we've already done 2 electrons. So 4 take 2 is, well, 2. And you can draw it absolutely anywhere. You can draw X's as well. So now we have 1, 2, 3, 4 electrons. So because that's how many electrons there are in beryllium. And we have also successfully followed the orbital rules, where in the first orbit there can only be 2 electrons, and in the second orbit there can be up to 8. So 8 would be the limit of the second orbital, and the same goes for the third. If there is a very much more higher number, higher atomic number, higher element that has a lot more electrons, the same apply. The first orbital would have 2 electrons, the second orbit would have 8, the third one would also have 8, and so on, so forth. And you also have to make sure that all the electrons that you draw out actually does add up to the atomic number. And another thing to also keep in mind is the places of composition, which we've already done. We know that within atoms there are neutrons, which have a negative charge and are in the nucleus. We also know of the protons, which has a positive charge and is also in the nucleus. And then we have electrons, which have a negative charge and are on the orbitals. The orbitals, the electrons, is what we draw on the orbitals, and there are 4 of them. So in this case, we have to draw 4 electrons in the orbitals. To go a little bit more depth into these 3 components, because this is where it starts getting a little bit more interesting. Electrons, specifically, they are one of the smallest of the protons and neutrons, but also their movements around the orbitals are so important. Their movement of how fast they go, if they fluctuate, that determines the chemical behavior of the element. And if the electron obviously moves more faster, that means that the charge of the electron is increasing. So this determines chemical behavior. But if we were to look at protons and neutrons, well, what's their purpose? Protons determines, well, like we've said, the identity of the element. This atomic number that you see, yep, that's because of the protons. So this basically determines the identity of the atom. Oh my goodness. But now the neutrons. The neutrons, it contributes to the mass. It contributes to it. Not solely, but it contributes to the mass of the element. It contributes to the mass of the atom, but that doesn't affect the atom's identity. The atom's identity is obviously the symbol, but also the atomic number. Those two are the most important. The mass doesn't really apply with the the element, because it can differ. So neutrons, it contributes to the mass. And the reason why I chose the word contribute is because to find out the mass of an element is by doing two things. It's not just the neutrons, but you add it to the protons. So the protons, they're basically doing two things. They're identifying the atom, but they're also, if you add it to the neutrons, that gives you the mass of the element. So if you want to write this out, the mass of an element, or any element, is that the total number of protons and neutrons added together. So when they're combined, that gives you the mass. So, example, if the neutrons are 6 and the protons are 6, that means the mass of the element will be 12. And don't mix this up with the charges. The charges and the number are completely different. The charges of neutral, positive, negative, that determines if the element is like stable or not, how it will chemically react with other elements, and so on and so forth. But the actual amount is what we would see on a diagram. This is the amount. Charges aren't like included in the diagrams, if that makes sense. So the amount of protons and neutrons, that gives us the mass.